The era of the F-22 Raptor, once the unparalleled leader of air dominance, is coming to an end. This cutting-edge fighter jet, which was long regarded as the pinnacle of aerial warfare, is now facing competition from a newer, more advanced supersonic aircraft, the NASA-developed quiet X-59 supersonic stealth plane. Designed to lead the way into a new era of faster-than-sound travel with reduced noise, the X-59 has aviation enthusiasts intrigued. But can this new aircraft truly surpass the legacy of the F-22 Raptor? What innovative features set the X-59 apart from the fifth-generation Raptor? Let's explore the technology and advancements behind the X-59 that position it as the next game-changer in aviation. The Lockheed Martin X-59 Quiet Supersonic Technology, QSST aircraft, is a highly experimental supersonic plane developed by Lockheed Martin's Skunk Works division under the direction of NASA. The primary objective of this project is to solve a long-standing issue in supersonic travel: the deafening sonic boom that occurs when an aircraft breaks the sound barrier. Previous supersonic planes, such as the Concorde, struggled with the loud shock waves they produced, limiting their use due to noise restrictions. The X-59's goal is to prove that modern technology can eliminate these barriers, making supersonic flight practical for broader applications. Development of the X-59 kicked off in February 2016 when Lockheed Martin secured a contract to build the aircraft, aiming for a first flight by 2020. By 2017, wind tunnel tests on a scaled model were underway, and design reviews were completed by mid-year. Although NASA received interest from 3 companies, only Lockheed Martin submitted a full proposal, leading NASA to award them the contract for full-scale development of the X-59. The standout feature of the X-59 is its ability to drastically reduce the sonic boom to a mere 75 decibels, which is equivalent to the sound of closing a car door. In comparison to traditional supersonic jets, this is a significant achievement. The X-59 achieves this low-boom performance with its long, slender body and uniquely shaped nose, which helps spread the shock waves more evenly as they pass through the atmosphere, reducing the jarring sound heard on the ground. Physically, the aircraft is a sleek 99.7 feet long with a wingspan of 29.5 feet, and it weighs 32,000 pounds at maximum takeoff. It's powered by a General Electric F-414 engine, which delivers 22,000 pounds of thrust and allows the X-59 to fly at speeds of up to Mach 1.5 at altitudes of 55,000 feet. The aircraft borrows components from other high-performance planes. Its ejection seat and canopy come from the Northrop T-38, and the landing gear is derived from the F-16 fighter jet. Notably, the X-59's engine intake is positioned on the top of the aircraft to reduce noise emissions further. One of the significant challenges the X-59 faces is its lack of a forward cockpit window, which is necessary for traditional navigation. To overcome this, the plane uses an advanced vision system, replacing conventional cockpit views with a 4K wide-angle camera as part of its external vision system, XVS. This gives pilots the necessary visuals for navigation and landing, while Collins Aerospace provides specialized avionics, including sensors to monitor sonic booms and infrared systems to assist with landings. In 2018, NASA's Langley Research Center conducted wind tunnel tests on a small model of the X-59 to evaluate its stability, control, and airflow dynamics. These tests were critical to refining the plane's design. NASA also launched public tests to measure reactions to sonic booms. In a trial involving 400 residents, each received compensation for providing feedback on daily sonic boom tests conducted over 2 weeks. Data from this experiment is being used to help regulators decide whether supersonic flight over land can be approved, with the potential for new regulations on sonic booms as early as 2027 and commercial supersonic flights by 2028. A key milestone in the X-59's development occurred in 2023 with the installation of its General Electric F-414 GE 100 engine. This 13-foot engine provides the necessary thrust to propel the aircraft past the sound barrier without producing the thunderous booms typical of previous supersonic jets. In August 2023, Lockheed Martin released footage of the X-59's rollout, showcasing the sleek design, and by January 2024, the aircraft was publicly unveiled. However, the central question surrounding the X-59 remains. Can it truly solve the fundamental problems of supersonic flight? Traditionally, planes flying at subsonic speeds emit sound waves in all directions, but when they break the sound barrier, these waves compress into an intense shock wave, creating the familiar sonic boom. This boom starts at the plane's nose and ends at the rear, resulting in a loud noise once it hits the ground. The X-59, with its revolutionary design, aims to reduce this boom into a quieter, low boom, rather than the ear-shattering noise usually associated with supersonic jets. But the true test of this technology will come when NASA begins flying the X-59 over various U.S. cities to gather real-world data on public reactions. These tests will determine whether the noise produced by the X-59 is quiet enough to allow for supersonic flight over populated areas. For the X-59 to succeed, both regulatory bodies and the public must find its low-boom technology acceptable. NASA's goal is to demonstrate that supersonic travel can be both fast and quiet, potentially transforming commercial aviation by allowing faster-than-sound travel over land without disrupting daily life with loud sonic booms. As the F-22 Raptor nears the end of its era, the aviation world looks to the X-59 for the next big leap in air travel. With its sleek design, cutting-edge technology, and promise of quiet, supersonic flight, the X-59 may well exceed the Raptor's legacy in numerous ways. Whether it will fully replace the iconic Raptor remains uncertain, but one thing is clear. The future of aviation, marked by quiet supersonic planes, is about to take off, forever altering the way we traverse the skies.